So we're going to take a slightly different tack. I took the opportunity to take a very broad, I guess, look at open and sustainable geodetic data, but then narrowed it very, very narrowly to examples from Australia. And it gets a little bit narrow, but please stick with me as we go through it, because I'm hopefully going to tell you about the success story that we've had in Australia as we've gone on this journey of convincing government and society that geodesy is important, and to invest in geodesy can bring meaningful benefits and have good impact. Oh, okay, all right. So a little bit about us. Our program at Geoscience Australia is called Positioning Australia. And so we've taken the lens of talking about it in the terminology of positioning and navigation and the benefit that geodesy brings to that. So we support the Australian government, industry and research throughout the definition of accurate and reliable positioning foundations for location information in Australia and its regions. Our role is to use the scientific knowledge and technical capability that we have to, I guess, provide that link between the infrastructure, the observatories, the data analytics, and the production of the products and the services that we put out. You can see that we host a range of ground infrastructure, and I'll talk about that a little bit more, and I'll also go into some of the products and the services that we're delivering. But essentially, the philosophy is that we do this entirely in an open manner. So the architecture of the systems that we're providing access to the products and services is open. The data is open. The products and the services are all entirely open as well. So this is, I guess, our super site out at Yarragadee, hosting almost everything that you could possibly want at a geodetic observatory. But it helps to link the conversation about how Australia is contributing to the global and the international efforts. We hold a number and a variety of roles across not just the infrastructure, but the analytics and the products as well. And I think for us, it all comes back down to this ability to provide an accurate and reliable geospatial reference system for Australians. So for us and for me, it's very much about that ability to demonstrate why positioning is important. And for us, that comes back down to datum. And this was one of the very early models that we used to demonstrate that having open access to datum, having the tools and the models and the transformations available online, easily accessible as a reference standard, made a huge difference in the way that people were able to interact and talk about positioning services. We've got technical manuals galore, we've got implementation manuals galore, and they hold all of the code, all of the transformation and the algorithms and the calculations that go into that. But we wanted to codify that to make it accessible. And essentially that's what GeodePy is. It's a Python package that sits online that we both embed operationally to do all of our transformations and the algorithms for the variety of models and datums that you have in a reference system. But it means that large software vendors can then compare their implementation of the transformation to our reference standard, and it exists, I guess, in a codable manner. So recently, well, not so recently, we're going on around year 7 of the program. We got quite a large investment of funding from the federal government to build a new positioning capability, but also to take advantage of the new technologies coming online. And it was sort of pitched as 2 new policies. One was around enabling better access to GPS for regional Australia. So the idea that you don't need to be in an area of mobile phone or internet communications to be able to access decent positioning. And then the second one was to better GPS to support Australian business. And you'll notice it is targeted at GPS. That was, I guess, a function of the times. It really is GNSS in a modern day and age, but GPS was used because that was more easily understood at the time in the circles that this was being pitched as a business case. And what we saw were the benefits coming out of that have been tremendous, and I'll go into some of those a little bit later. But again, the philosophy sitting behind it was to enable better access to positioning services underlined by an open data, open analysis, open infrastructure policy. And so the two main projects that came out of that big new funding were the Southern Positioning Augmentation Network, which is essentially a satellite-based augmentation system that's been co-developed between Australia and the New Zealand governments. Essentially, I think if you're familiar with WOS or EGNOS, it's similar to that, just for our region. We didn't have one previously, but we have one now, and it's working really nicely, which is great. And you'll notice the tagline, early open services, again, trying to hit on that open availability of decent positioning services. And the other part of it was investing in the positioning infrastructure, and that was very targeted at GNSS infrastructure, where the idea was to create a uniform network across Australia. So we had the scenario where GA maintained, owned, hosted and operated our core GNSS network, which we use for geodetic reasons, for defining datum and aligning the reference frame. But we saw, I guess, the explosion of RTK services, and there were only really 2 or 3 in Australia, and they were quite expensive. And so it was limiting access to innovators, to startups, to new businesses trying to invest in Australia. And we wanted to smash that barrier, essentially, and open it up to allow that research and development and innovation to occur in Australia. So I'm not going to go into all of this, but as a snapshot of the GNSS, I've kind of aligned the focus here. These are the GNSS style services that come out of Southpan and NPIC. So we've got our good old regular real-time RTK network that's pumping out over RTSM via NTRIP. And then the variety of SBAS services there being the legacy L1 only, a dual frequency multi-constellation transmitting on L5, which is both for GPS L1, L5 and Galileo E1, E5A, and then a PPP via Southpan. And so those are the corrections delivered via satellite, but then those are also mimicked and delivered via internet, if that's how you like to access your positioning services. And then we also have SSR streams as well, coming out as a PPP, essentially PPP correction. But that's not all we do. These are the other GNSS products and services that we also provide, again, with the open philosophy for the purposes of helping society, helping the Australian economy, and continuing our contributions to the global and international communities as well. In Australia, we have an interesting capability under the National Measurement System at GA. We're a verifying authority for position. So it means we have the ability to provide traceability from a GNSS cause site back to the datum. And there are some legislative requirements around surveys that must connect to datum. And so they get their GNSS cause site verified essentially by us that it is where they think it is. It's where we think it is. And we provide that with a level uncertainty such that if that site breaches that tolerance or that uncertainty, it's no longer certified as being able to legally connect to datum. Again, we do that openly. We see that as a service that benefits society. It links to the legislative frameworks, it links to the measurement system framework, and we see it as an important part of how we do business in Australia to enable that access to positioning. And these are the impacts. This is the why bother. I really like this slide. This talks about some of the economic benefits, but also the societal benefit and the societal impact that positioning has. So these came out of some of the early studies that were done around why would you bother investing in an augmentation system in Australia or in the Pacific or in New Zealand? And these were some of the numbers that came out of it. So if you're taking a business case to government, they want to know what their return on the investment is going to be. So they want economic benefits. But what was really neat were the stories that came out around the societal benefit and the societal impact that positioning and good geodetic products and services have. And so hopefully you've had a chance to browse some of those. I think my favourite story was around helping the visually impaired navigate themselves through complex environments. So we ran a case study or a test where they were wearing a haptic belt that was enabled with a positioning service, and that allowed them to identify with the sort of the vibration or the haptic feedback when they were entering an area where they needed to be cautious. So say they were approaching a staircase, it would give them a vibration to let them know that they were approaching an area they should be a little bit careful around. And to me, that it just resonated that the importance goes beyond science, it goes beyond research, it goes beyond money. It has value to everyday people. And so there are a couple of stories and pictures around the value proposition about the positioning infrastructure side. So again, sticking with GNSS, it needed to underpin our geospatial fabric. That was the term we went to try and describe the reference system and the reference frame in our datum. It needed to support and encourage innovation and research, and it needed to be a platform for Australian business. So again, trying to hit that innovation target. And this is how we did it. We unified our network of positioning infrastructure. So we upgraded and modernised the existing infrastructure that we had, but then we also built new stations in areas where there were gaps or the network geometry wasn't so great for the GNSS cores. The digital delivery platform underneath, so it's not just physical infrastructure, it was the digital infrastructure was modernised and updated. Essentially, that meant we rebuilt our Entripcaster from scratch, and it's now called AusCores. And we built an entirely new piece of software to do GNSS and other analysis, which is our GNAN PPP toolkit. And I think the distinction for GNAN is that it was built from the beginning with an entirely open source philosophy. So trying to encourage people to contribute, but then also provide it as a platform that people could take and innovate with themselves. And so what does it look like? Essentially, this is our GNSS network today. This is what we consider to be our fundamental fiducial network. So it's now been expanded to 200 stations across Australia, which I think in IGS terminology would be our tier 1 sites. And we haven't done that alone. I think that's the other part of this program. We didn't aim to do it by ourselves. We really strongly, by necessity, collaborated with our friends and our partners across state and territory governments. We outsourced some of the construction, so it wasn't as if we went out and built them ourselves. That was going to be far too complicated with a big project like this. But then the other, I guess, neat part of it was that we this is what a typical site in Australia looks like. Some of these are fairly remote, so they've got no power, so you've got to rely on solar and battery backup. They've got no communications, so you're putting up a satellite dish as well. And sometimes to get the concrete pier established in a bedrock location, you've got to dig quite deep. So I think that's just a nice picture to demonstrate what some of the sites look like. And then the second part of investing in the physical infrastructure was to sign data sharing agreements with the existing networks that already happened. So we didn't want to go out and just keep building new sites. We wanted to recognise that there are existing networks in Australia and we can leverage those. And so we've now got data sharing agreements that essentially open up the network to over 700 stations across Australia, where that data is freely accessible. The majority of these sites are streaming real-time data, and you can see the network partners that we've worked with to make that possible. And that brings me to our PPP toolkit, which we've built from scratch. We've called it GNAN, which is a Waterman word for a red dilly bag filled with songs of knowledge, but it's also the name of one of the stars in the Southern Cross. And so the link between traditional owners in Australia and their ability to navigate using the stars, but having sort of that collection of knowledge to be able to pass on really resonated with me, which is why we called it GNAN. But essentially, it is operating off a PPP algorithm. You're in really simplified terms, you're gathering the parameters of interest that you want to take a look at. You stick it through a Kalman filter and out pops your parameter of interest. It's incredibly powerful. It's modulated so that the functionalities can be isolated as to what you're interested in understanding. And essentially, it's a GNSS super analysis piece of software. And I'd encourage you to take a look. As I mentioned previously, it was built with this open source philosophy in mind. So it's entirely, the source code is up on GitHub. We've implemented it operationally at Geoscience Australia to demonstrate that that's possible. We've gone and run some wacky experiments, such as putting Ganaan on a Raspberry Pi to run as the PPP engine, attaching it to a weather balloon and launching it up to 30 kilometres in altitude to try and look at what the troposphere delay is doing as you hitch a ride on a weather balloon. So there's some fascinating case studies. I'd encourage you to go and have a look if you're interested. But the open source philosophy means that we've seen people pick it up and use GNSS for applications that we had no idea existed. It's driving innovation, it's promoting research, and we're very excited to see what else could be done with it. So please pick it up, have a play, break it if you can, tell us how you fixed it, and we'll implement that fix. I mentioned previously, I won't go into it because I realise I'm running out of time, but it wasn't just about the physical infrastructure. We've also focused on the the digital and the data infrastructure that sits behind our positioning capability as well. And so this was the rebuild of our NTRIP broadcaster from scratch. It now supports something along the lines of almost 20,000 connections at any one time. So people are using it heavily, and it's standing up to that use, which is kind of impressive. And these are just some of the stats and the coverage area across Australia. And I know that the team are very pleased and very proud to promote that their service availability was at the 99.9% during last year. So I think I'm going to wrap it up there and kind of close out by saying that making data, infrastructure, services, products open sits at the core of this community. And to talk about that is important as well. GGOS plays a role in promoting geodesy, but I think we can also promote how geodesy is used and the fact that we're all doing it together in an open manner. Thank you very much.
Thanks very much. Any questions for Matt?
Thank you. Thank you very much for an amazing presentation. I have a short question. Could you please share the time frame, the moment, the launch of the project, and the time approximately you're going to reach your goals with the reference frame and then models and accuracies? Thank you.
Absolutely. So the first investment was in the 2018-2019 financial year. So since then, we've completed the establishment phase, which for us was getting Southpan to its early open service point, and for the national positioning infrastructure to get to the point where all 200 sites are unified and working online, and we've now hit that goal as of about July this year. So it was quite a long-term project. The next phase will be sort of the sustainment, maintenance, and implementation of Southpan will reach we're hoping a safety of life certification in 2028. And now it's embedding sort of the operational capabilities at Geoscience Australia for both the positioning infrastructure side and our analytical toolkit.
Yeah, thank you. Do you have a question of our online audience?
Oh.
Let me see.
Someone raised a hand, so
Yeah. Was it Graham? I think you raised your hand online. I noticed that pop up, but it's come down again.
Yeah, hi. I did raise my hand and thought that the previous question sort of answered. My question really was, it's a brilliant network. You fairly modest precision requirements at the beginning. You're talking about 5 or 10 centimeters. Presumably you will want to ramp that up in the future to sort of meet the GGOS aims.
Yeah, so you've picked up on a technicality, so those numbers were around the real-time capabilities out of the network as a whole. So clearly for the geodetic applications, we're going to drive that down almost hopefully by an order of magnitude. And at the moment, what we've seen is that our existing network is meeting that in terms of our regional reference frame, but also our national datum. But yes, those numbers were pitched as the real-time ability to achieve a positioning accuracy.
I guess as a business case, you'll need to sell that as all the business cases that you've mentioned, and then the geodesy comes sort of later, having established.
Yeah, it's very hard to sell geodesy. I mean, the message we took was that everything you do with position or location is underpinned by your ability to do geodesy. It's the infrastructure that sits behind it. And without good investment in the fundamentals, you're not able to achieve those positioning accuracies.
Yeah, very interesting. Thank you.
And one question, one quick question. You showed also the core sites in Australia, and there have all these techniques, the geodetic techniques, and also Doris very close to the other techniques. Is there any problem? Do you think problem doing this? Because usually the Doris transmitter is far away.
Yeah, look, if Lucia's online, you're probably better to ask Lucia, but I know that at Yarragadee they put the Doris beacon as far away as they could from the VLBI. I'm not aware of the interference that is caused between the various techniques. Yeah, question for somebody else, I'm sorry.